Okay, now that we've seen an example, let's try some ourselves.
Oh, come on now. How am I supposed to count you all if you keep on running away? It ain't easy being a census taker in the swamp.
Okay, here we have a question involving a percent that's greater than 100. We can use that percent equation to help us answer the question. This question says that a study found that the alligator population this year is 120% of last year's population. If last year's population was 60, how many alligators are there this year? All right, we're going to use that percent equation. So we'll write part equals percent times whole. Writing this down is a good place to always begin whenever you have a percent question. Okay, now I gave you two keywords earlier that help you identify the part and the whole. Is and of. We have our percent. We can either write it as a fraction or as a decimal. I'm going to go ahead and just write it as a decimal. That's what most students prefer. We always move the decimal place twice to get the decimal version of our percent. So 1.20. All right, we're looking for those keywords. It is and of. This year is 120% of last year. So this year is the part, last year is the whole. Is for part, of for whole. So it says that last year's population was 60. Last year is our whole. We're trying to find this year's population. This year is our part, and this year we don't know. So we can use the variable x since we don't know the part. Well, according to this percent equation, we just need to multiply 1.20 times 60 and we will find the part. We will find the answer to the question. $72. That means that there are 72 alligators this year. Oops. Whoa. Let's try that again. Now, earlier I mentioned, and I had you write down what the percent proportion is. I just want to show you real quick. The percent proportion is another way to solve percent questions. It's just like a different way of thinking about it or doing it. Now, whenever people use the percent proportion, they actually will kind of for short do P over 100, where P stands for percent, equals is over of, since is your part and of is your whole. This is just the way I've seen a lot of teachers and students write the percent proportion. So our percent, we know, is 120. We actually just leave it as 120 because we're writing it over 100. So we're writing it in fraction form whenever we do the percent proportion. The part is unknown and the whole was 60. You can use this proportion to help you answer the question as well. You would cross multiply. This is something you did last year. X times 100 is 100x. Since whenever you have a number right beside a variable, it means to multiply. 120 times 60. Well, you can do that real quick on the side, or you can use a calculator. 7,200. To solve for x, we would divide by 100. 100 divided by 100 is just 1x. 7,200 divided by 100 is 72. So we got our answer just in a different way. You can use the percent equation or the percent proportion. I think today and for now on, I'm just going to stick to using the percent equation. All right, here's another question. During harvest, a cranberry bog is flooded with water to a depth of 4,800% of its usual depth of 1/4 inch. How deep is the water during harvest flooding? Okay, I'm going to write down the percent equation. Part equals percent times whole. I definitely know my percent. I want to write it either in fraction form or in decimal form, but I'm just going to stick to using decimals like we have been. Remember, if you want to change a percent to a decimal, you can just move that decimal over 2 times. So really, this percent is just 48. The whole number 48 is the same as having 4,800%, because it's like 48 times your 100% original amount, like we kind of talked about earlier. Then I see that keyword of. It says of its usual depth of 1/4. So 1/4 is our whole. Again, we don't know the part. So to solve this, we would do 48 times 1/4. You could give 48 a denominator. 48 times 1 is 48. 1 times 4 is 4. 48 divided by 4 will be 12. And this is in inches. So the water is 12 inches deep during harvest flooding compared to 1/4 of an inch deep. That's a lot of times deeper. That's way deeper. And that's why we have such a large percent. Okay, this one takes out all the crazy details of maybe a word problem that could be more confusing. Just pretty simple. Let's try it together. We have the percent equation that can help us solve questions about percents. Part equals percent times whole. I'll always begin by writing that down. Now this question says 96 is what percent of 12? This question, we don't know the percent, so that's our unknown. But we do know the part and we do know the whole. Use those keywords. 96 is of 1/12. 96 is the part, not 1/12, but just 12 is the whole. Okay, we've kind of seen problems like this already in our last topic. We're trying to do a multiplication problem, but we already know the answer to it. We got to work backwards. Divide. (96) divided by 12. That gives us 8. But we're looking for a percent. It says what percent is it? It's not 8%. 8 is a whole number. One whole is worth 100%. So 8 as a whole number is worth 800%. We're moving that decimal backwards this time to make our percent. Just like earlier we were moving it to the left to get our decimal. All right, we're on to the last part. Again, we're just going to be thinking about what percents greater than 100 really mean. So we'll go through each and classify it as true or false. A pet grasshopper jumped 6% higher than his old jump record. Well, his old jump record used to be his full, complete jump. His old jump was 100%. So if it's 6% higher than 100%, that's 106% of his old record. True. An ant weighs 3 milligrams. The ant picks up a 30 milligram leaf. That is 10 times the size of the ant. So he's picking up something that's 10 times his own weight. 10 times his weight. Well, all of his weight would be 100%. 10 times 100% is 1,000%. So this is false. It should be 1,000% of his weight. Lastly, The wingspan of a monarch butterfly is 2.5% greater than the wingspan of a queen butterfly. Well, the queen butterfly has 100% of its wingspan. It's the complete and full wingspan. So if the monarch's is 2.5% greater than the queen's, that's 2.5% greater than 100. That's 102.5%. 2.5% greater than 100. So again, they made a mistake, and this statement is false, but we have corrected it. An artist is making a wall mural from a small sketch. He enlarges the 4.5-inch wide sketch to 900% of the original size to create the final mural. Earlier, we talked about how 900% would be like 9 times as big. Which statements are true? The mural is between 36 and 45 inches wide. Okay, what was 4.5? And we're going to do 9 times that much. 4 times 9 is 36. 5 times 9 is 45. 4.5 is in the middle. This is true. The final width of the mural is 4.5 times 900? No, it's times 9. That one's false. The final width of the mural is 9 times the width of the sketch. Yeah, that's what we said. So choice 3 is true as well. One more. Student A says a 200% increase of 24 is 48. Student B says 200% of 24 is 48. Who is correct? Explain. Be careful with the way they're wording this. See if you can figure it out. Pause the video maybe. Think about it for a minute and then see if you were thinking correctly. Okay, 200% of 24 is 48. Okay, 100% of 24 would be 24. 100% of 24 is also 24. So 200% of 24 would be 48. Student B is right. Let's look at student A. A 200% increase of 24 is 48. If you increase something 200%, that means you're starting with 24 and then you're increasing it by 200%, which is 48, and that would be 72. Increasing it by 200% is different than just doing 200% of it. Increasing it by 200% would be starting with 24 and then adding even more. Finding 200% of 24 is just 48. So student B is correct. Okay, so throughout this lesson, we've learned several things. And like I said, they do expect you to already know a lot about percents. So I hope they are getting the hang of things. But basically, we learned and worked with what having a percent over 100 even means. And we also worked with using that percent equation to answer some percent type questions. All right, good luck with your homework, and I'll see you next time.